Students, today's topic is physics at the end of 19th century. This physics at the end of 19th century is also, you can say, famously known as classical physics. Okay, at the end of 19th century, the physics actually consisted mainly three branches. That is classical mechanics, theory of electromagnetism, and the theory of thermodynamics. Okay, these were the three branches of physics which were the part of physics at the end of 19th century. Okay, so the classical mechanics can be used for studying the motion of microscopic objects. You already know. Okay, and the electromagnetism, which is also known as Maxwell's theory or the classical theory of electromagnetism. This is the unification of electricity and magnetism. And this theory, you can say, provides a mechanism and the techniques for studying, you can say, the behavior of the radiation or the properties of the radiation. Okay, now comes uh, into the thermodynamics. So generally, thermodynamics is used for studying the interaction between energy and matter, or the interaction between, you can say, the radiation and matter. Okay, so uh, we already know that thermodynamics is actually about the heat flow, and so generally, it is said to be, you can say, used for studying the interaction between matter and radiation. Okay, and then comes the failure of the three branches of mainly the three branches of classical physics. Okay, the classical physics failed in providing, you can say, correct results at relativistic and microscopic levels. Okay, so there are two levels, there are two domains where the classical physics was found to be badly failed. Okay, so the relativistic level is that level, or the relativistic domain is that domain where the particles move with the speeds which are very close to the speed of light, right? So over there, the classical mechanics was found to be failed, right? Because the results of the classical mechanics do not match with the results of the special theory of relativity, which was proposed by Einstein in 1905. And this special theory of relativity can deal with um, the motion of bodies which move with a speed so closer to the speed of light. Okay, and the second level where classical physics was on to field, that is microscopic level. Okay, so over there the classical physics failed in providing accurate results about processes of microscopic particles, right? Right. When compared with experimental results for the microscopic work, means there were some experiments performed, you can say, in order to study the processes that take place at the microscopic level, and it was found that the results of the experiments are not same as the results provided by classical physics. In other words, classical physics failed in providing any explanation about the processes which take place at a microscopic level. Okay, so that's why this was second domain where the classical physics, you can say, fails. And these microscopic processes are the microscopic phenomena which take place for those particles which are microscopic, right? Means those particles, so those processes, those systems cannot be, you can say, seen with naked eye. They can be called as microscopic systems. So for the microscopic systems, the processes which take place, they include, for example, black body radiation, photoelectric effect, atomic stability, atomic spectroscopy, Compton effect, and so on, etc. And the details of these processes can be found in next coming lectures. Okay, so these are the famous, you can say, microscopic processes where the classical physics fails at a microscopic level. Okay.